Okay, we're rolling with stop doing that, that's a bad habit. Hello, and this week's lecture we're going to look at digital imaging file formats. You know all those file numbers letters that you see, JPEGs, TIFFs, RAW files, what does it all mean? Well, this lecture is going to explain exactly that. So in this lecture we're going to look at pixel-based versus vector-based images. We're going to look at and examine the different types of file formats used in digital imaging. We're going to look at the what, when, how to use these different formats and what makes them different. The term pixel derives from the expression picture elements, and pixels are used to create digital images. The image is made up of millions and millions of individual picture elements, and they designate a particular color value or RGB value and tone. If you look at a low-res image like the one you see on the screen here, you can actually see the pixels, those square little boxes. And these are pixel-based imaging is actually used in our photography. So digital imaging uses pixel-based format. The other type of digital image that you may be accustomed to are vector-based images. And vectors are points or lines and curves or polygons, shapes, if you like, on a mathematically formed grid. And unlike pixels, vector files are independent of image resolution. Vector-based imaging is used in graphic design applications where typography and images are actually combined. Another concept that you might hear around photography is this concept of lossy and non-lossy programs or file formats. Digital images are generally quite large in size and require a lot of memory, a lot of digital memory. We can compress these files to make them a little bit smaller, a little bit usable. The difference between lossy and non-lossy compression is as the terms are pretty self-explanatory, really. Lossy compression means that it removes the redundant file information. Now, once this redundant file information is deleted or lost from the file, it cannot be restored. So lossy compressions are file destroying in the sense they actually throw out or delete any unused areas that the file doesn't contain. Non-lossy, however, allows all information to be restored in a compressed file. So it still has the function of compression, but it retains all that information in a compressed format. Lossy compression can compress greater, has a greater level of compression, and non-lossy compression, it's sometimes difficult to get it down to a very small size with some of those type of formats. However, if you want to restore it, all the information's there. So lossy and non-lossy formats, lossy makes any unused data redundant or destroys it, whereas non-lossy retains all the unused data but still compresses it. So what are file formats? And this is one of the most, I guess, confusing elements of photography when you first start. Photography is a very jargon-orientated industry, but they really are only expressions and words, and by the time you get through this course and others through the program, you'll start to use these terms just as readily as everyone else does. File formats are the digital imaging file application that encodes the data to perform a particular characteristic. Characteristics may include the type of compression, the type of bit depth, the archive quality, or the purpose, whether you're printing on inkjet images or exhibition quality prints on digital printers, or whether you're producing an image for the web or a web page. The file format is the designated 3 letters or numbers after the dot in the file. And you can see just here, if I just highlight that area there, this is the file name, and you've got a dot, and then that is the application or the file format. There are several different file formats available with digital imaging, and we're going to have a look at some of the most common ones now. The 4 most common file formats or applications for digital imaging are JPEG, RAW, TIFF and PNG. So JPEG is designated with .jpg. RAW can change the file application, those 3 letters or numerical values and letters can change with RAW, and I'll explain what I mean by that later. And TIFF and PNG is just abbreviations of those terms. So let's first of all have a look at JPEG. And JPEG's the old boy of the digital imaging formats, really. It's probably the most common one used, and it's most readily accepted around a lot of different applications. So JPEG, short for Joint Photographic Experts Group. Not many people know that, and it's really not. You don't need to know that. JPEG is a format that can be shot, and it's available in all cameras. I don't know of a digital camera that isn't available has JPEG as an option, or it may only shoot just JPEGs. It's the most popular format for enthusiasts but not professionals. JPEG format is the format that we want you to use throughout this semester, and there's a reason for that, because we don't want to complicate the post-production and processing that needs to occur with other types of formats. So we're keeping it simple for the first semester. But later on in next semester, we will upscale you into other types of formats and better quality ones. JPEG offers the fairly extensive file compression. It's a lossy method, so it allows greater compression, but unfortunately, as the data is lost, if you're going to work on that image later in Photoshop or other types of post-production editing software, you're going to find that you can't actually correct for certain things if they've been lost or destroyed. The JPEG compression is also a variable. You have low, high and medium compression, and JPEG is only offered in 8-bit. Now, bit depth is a really important concept when we talk about image quality and photographic quality. We're not going to talk about bit depth this semester. We certainly will talk a lot about bit depth in semester 2. So JPEG, definitely the most common file format for digital photography. It allows extensive file compression, so it's good for the web, or it's good for Facebook, or if you want to use images in a small image file format. Its compression rate can be varied from high quality down to low quality, but it's only offered in 8-bit. I might also add too that JPEG format is processed through the camera, not through a computer. Now, the second file format that you should be familiar with is a TIFF file. TIFF files are called tagged, or short for tagged image file format. Again, that's redundant information. We don't really need to remember that, but that's what it does stand for. And TIFF is not generally supported by most cameras. I have seen some cameras that support TIFF files, mostly around more scientific-based cameras rather than the standard digital SLR. I haven't seen any digital SLRs that actually shoot in TIFF, but there could be some out there. TIFF is what it doesn't compress, resulting in a large file, so it's awkward in the sense of compression. It's not suitable for the web. TIFF is mostly used for printing images onto through digital inkjet printers or through bureau printing organisations. JPEGs can be printed as well, but TIFF usually offers a better quality print if it's formatted properly. The idea of TIFF format, however, is its flexibility across different output devices. So TIFF is commonly accepted by a lot of different formats. So scanners, computers, printers, all accept TIFF. And the last point there on the slide, ideal format for digital printing and graphic reproduction, images printed in magazines, journals, books, and so forth. So I mentioned that digital printing from inkjet printers, TIFF is the ideal format, but it's also the most common format used for graphic reproduction. And graphic reproduction are images that are used in books, magazines, catalogues, high-end sort of printing by printing presses, not the digital printing photographs that we're kind of used to. When you go to, when you're shooting for a client and they require the image for graphic reproduction, you may have to produce that image for your client in a TIFF format. In academic work, where academics write papers and publish images associated with those papers, those journals, which are basically magazines in a sense, they also require images that are in a TIFF format. Now we come down to raw files. And raw files are very different to TIFF and JPEG. RAW and JPEG are usually the two common capture formats that cameras offer. They have usually the high-end cameras will always have RAW, and JPEG is an option for the capture format. TIFF is generally a format that's applied during post-production, so through Photoshop and so forth. RAW, as the name suggests, is unprocessed images. So they shoot at the image and they don't actually process them. When you're shooting in RAW and you're looking at the back of the camera, you're actually looking at a JPEG image of that RAW file. But nevertheless, you don't save that JPEG, it just keeps the RAW. So RAW photographs or RAW files can't actually be imaged, can't be seen until they're processed. Once the image is processed through a variety of software, ACR, Adobe Camera Raw, or Photoshop, they can be saved as JPEGs, TIFFs, or PNGs. So RAW's a image capture format that retains all the information in a processed format. It also shoots at 12 to 14-bit depending upon the bit depth of your camera. JPEGs are 8-bit, but RAW files are generally 12 to 14-bit. Now the big difference between a JPEG image and a RAW image is generally the bit depth. And bit depth controls the tonal range of the image, the amount of variety of shades that you might get across each tonal value. The ideal format for RAW is when we process that RAW file, we process it in 16-bit. Now we capture it not quite in 16-bit. When cameras will get to that stage where they do all shoot in 16-bit, that'd be great, but they generally don't. They fall a little bit short, but we do our processing, our post-production in 16-bit, and it makes a huge difference when we process in 16-bit rather than 8-bit. Now the interesting thing about RAW files, unlike JPEG and TIFF, RAW files are also proprietary files. So if you have a raw file from a Canon camera, it'll be a specific Canon raw file format. It's not if you have got using Nikon cameras, it'll be a Nikon file format. So most cameras will capture RAW, but in their proprietary RAW format. Now this causes all sorts of trouble when you try to sync it with other equipment, but it does need to be processed anyway, so it's not too much of a problem. Just another thing that I'd like to talk about, the difference between JPEG and RAW, is that what JPEG is generally doing, no, I'll cut that out. I'm talking about that later. Okay, so what we have on the screen at the moment is actually all the different camera manufacturers and their RAW file application. You can see Canon has the CR2, Nikon NEF, Kodak have changed their RAW application file, those 3 letters or numbers after the dot, the last dot, so DCR, K25 or KDC. Epson usually associated with printers, but they do have some cameras there, ERF. Leaf cameras, MOS, Sony, ARW or SRF or SR2. Phase 1 is and Hasselblad and Mamiya medium format cameras, and they have their different type of file format again for RAW. Olympus, Pentax and Panasonic back to the 35mm or digital SLR, and they have different file applications as well. But all those applications after the file format are all considered RAW. They're the same in the sense that they're raw and unprocessed, but they're different in the sense that they're proprietary software or proprietary applications. Now another file format is DNG, and DNG actually means something. It's digital negative. And DNG is also a raw file format. But the interesting thing about DNG, it was developed by Adobe, and it was developed by Adobe for an archival quality or an archival purpose. Now, one of the terrible indictments that we're going to place on our future generations in digital photography is whether our digital images are going to be able to be read by some type of equipment 100, 200 years into the future. Who knows what type of imaging and computer devices they're going to be using, but it's kind of unlikely that they're going to be using the formats that we use today. So unlike, I guess, film-based technology, where we can still pull out of our archive a glass plate negative and make an image from that negative. We can do it in some type of optical device, whether we rephotograph it or scan it, we can get an image from it because the image has some permanence and it's a tangible image. Electronic images or digital images don't have any tangibility, they are virtual. They're just code. So we're going to have a terrible lack of history. We're going to have all this wonderful vision of our history from 1800s up to the sort of 1990s when digital became popular, and then very little after that. So the Adobe company thought that what they might do is develop a raw file as a digital negative, equivalent to what our negatives would be in the old film days, purely for archival. Unlike the proprietary raw format files, they are proprietary and they're intellectual licenses, and if anyone wants to use that in their software, they have to pay the company a license. Well, Adobe DNG files, or Adobe developed the DNG files to be open source file formats, which means that they publish their file code, and anyone can actually apply that code sometime into the future with some sort of computer equipment and will be able to get the image. So DNG is considered as a way of archiving your raw files maintaining their rawness or lack of processing, keeping them in their original state with all their original code and the original information. No images, no loss of image. It's not lossy compression. No compression. It contains all the information, but in an unprocessed form. So DNG is designed for archival quality. I personally use DNG. I save all my raw files from my Canon cameras and I convert them to DNG when I'm uploading them into the computer system. And we can show you how to do that at some stage, or you can learn how to do that when you're uploading images from Adobe Bridge. Now another file format is PNG, and you'll see a lot of PNG files when you go surfing on the net. It's high compression format in a similar context to JPEG, very similar to JPEG. I don't understand what PNG, I've never converted a file to PNG. All I've noticed is that there are a lot of images on the net are now PNG. It's suggesting that my research suggests that it's better than JPEG because the image and text are used. There's no jagged lines on the text, so that's maybe why they're using them a lot on the internet when there's text and image. Conversion to PNG is achieved by image editing and not the capture. No camera actually captures in PNG. It has to be processed or done in the post. And PNG is not used for printing images. Unlike JPEG, JPEG can actually be used for printing. Another file format that you're probably familiar with is GIF, and graphic interchange format. GIF is a non-lossy compressed file designed for images on the web. They're not used in digital photography. They're used in these vector-based type graphics, and they have some animation. They're always associated with animation, moving image, just like the image you see on the screen now. PSD is something that you will use a lot. PSD is a Photoshop file. And when you start using Photoshop, not so much this semester, we just want you to focus on camera operations this semester, but next semester you will get to use Photoshop quite extensively. And what you'll learn with Photoshop is that when you start editing images in Photoshop, you start producing layers. And a PSD format allows you to retain those layers. So at a later stage, if you want to do more editing on each layer, you still have the image in that layer format. Layer format having different layers means that it has lots of different images, and that increases the file size enormously. PSD or Photoshop file formats are really about maintaining a file in an editable format. It's not used for printing or any other output. It really is to maintain your edits as you are, what you're up to at that particular stage. If you wanted to print the image after you've done your post, you need to convert it into TIFF or JPEG or another format. Now the $64 million question is JPEG versus RAW. What's the best? I get that question a lot, particularly from amateur photographers who shoot exclusively on JPEG, and because RAW is too hard and it's too much bother because you have to do the post or the processing. But there really is no comparison. Serious photographers shoot RAW and process into TIFF if they're making prints, JPEG or PNGs if they're using images for the web. RAW capture is really the only professional format that we use in the capture stage. Now it's a little. I need to also confirm again. This semester, first semester, we don't really want you to shoot RAW. You certainly can if you like, but we want you just to focus on JPEG because it's about the way we want you to teach you about how to use the camera, how to use creative controls, how to control exposure, how to compose the image, how to be creative and look at the aesthetic aspect of image design. We don't want you to get too technical into the post-production at this stage, but there's lots of time for that yet. So just recapping, the difference between JPEG and RAW. JPEG is, well, I guess I should explain a little bit more about what JPEG does. I mean, that is that the camera will always actually capture it in RAW, but if you've got the camera setting on JPEG, it will capture it in RAW and then process it. So what JPEG at the capture stage is really all that you're asking the camera to process the RAW file into a JPEG format for you. So it's a JPEG in capture is actually a processed RAW file, but it's processed into an 8-bit file, and the big difference is when you go into post-production, into Photoshop, and you're trying to do edits on an 8-bit file rather than a 16-bit. That makes a huge difference in your tonal range and particularly your ability to do subtle and fine tuning. That's really the difference between the professional editing and the not so professional. So RAW file is what captures, what all cameras capture at, but we would like, for high quality purposes, to process the file ourselves rather than the camera automatically processing. And don't forget, JPEG is a lossy file, so once it's thrown out that information that it doesn't use, you cannot get it back for the post-production. Now, one of the things that you will notice in your tutorials, particularly in your tutorials with our internal students, we will show you what type of JPEG format. In the Canon digital SLRs that we use, there are different types of JPEG formats. I think you've got 4. Large file, large. I don't really know all the types. I don't know what they refer to them as, but there are certainly a lot of different types of JPEGs. There's 4 different JPEGs. There's 2 large. No, there's 6. There's 2 large, 2 mediums, and 2 small. One. There are slightly different processing that occurs with a JPEG. There's a smoothing of the edges, so you don't get jaggies, and that's part of the algorithm. But the file format that you need to use for your assignments, I recommend you shoot large JPEG. Shoot large JPEG because what we will do in Photoshop, and this is what you will do in Photoshop, one of the applications in Photoshop, is to resize the format for the actual assessment. So that's pretty easy to do on Photoshop, and we'll show you how, and I'll have a little instruction video to show you how to do that as well. But file format for your assignment work, shoot JPEG at the largest JPEG format. The other aspect of shooting with Canon and Nikon is that sometimes you also have the option for RAW and JPEG. You can actually capture RAW and JPEG simultaneous. Because remember, really, the JPEG is a RAW file that's been processed from. The JPEG is a image that's been processed from the RAW. So you do have the facility to actually save both the RAW and the JPEG. If that's what you want to do and use the JPEG, that's fine. That's not a bad idea actually. You can shoot both JPEG and RAW simultaneously. Use the JPEG image for your assignments this semester. But if you actually get a cracker of an image, you've actually got it in RAW format as well to do some post-production when you learn a little bit more about Photoshop and how to get the best out of your images. So shooting JPEG and RAW is fine, but we do recommend that you only use the JPEG for your submissions. Okay, so that just about does it for image file formats, digital imaging file formats. I hope it's given you some clarity about all the different terminologies that we use with file formats and give you some perspective on when to use them and when not to use them. But as I said, just shoot JPEG at the moment, and there's more to come in later parts of the degree. So thank you, and talk to you later. Bye-bye. Done.
Cool.
Thought I was a bit more relaxed then.
Yeah.